Yo, what's up? How's it going? You already know who it is. It's Key. I'm just here for another stream with some GoLang, langing it up, going it up, langing it up. Okay, anyways, let me stop. My humor is terrible. Let's just get to it. Okay, so this is stream number 4. Um, I'm back. It is 11 o'clock on a Sunday night, and I got work tomorrow. So I don't know how long this is gonna last. But I feel very inspired to go here just to, keep at it. One thing I really feel is like, it doesn't matter how bad you are at something. It doesn't matter how new you are at something. It don't matter whether you just started yesterday or you've been doing something for a long time. No matter what, you will get better the more you do something. And that is worth more than gold. So when you have that inspiration and you're like, you know what? I'm ready to put in some work. Just do it. You'll be thankful. You won't have every day where you have that kind of energy and zeal to get on after it. But when you do, you should be grateful and appreciate it. So I'm gonna stick by that. That's my truth, and that's what we're doing. So let's go ahead and jump into this today. Let me go get my screen switched over. Um, so we're doing GoLang intro 4. I think this might be the last intro that I do um, because I think after this, I will have touched base with most of the things that I think I need to start making like little fun apps. I actually have the next stream already ready. I'm gonna make a little mouse themed game, a little terminal based maze game. It's going to be real simple. I already have the code written for it, but I don't. But the code was partially generated by AI, so I don't like completely understand it. So the point of the next stream is going to be to work through that code to understand what's going on, and then to use that as a bridge to start imagining how to extend that in my own fun creative way, if that makes sense. So I'm like kind of leveraging and building off of it. So that's the intention, that's the goal. And then, from there, I'm going to probably switch up the stream a little bit. I'm going to start doing more of my own things, less tutorials, less reading from the book per se, and more like making little apps and stuff like that. I'm gonna do the typical stuff like make a calculator, server side stuff. I've already made some servers before, but I'll make a new server. All sorts of cool stuff like that. So today we got concurrency, which I looked at last time, but I want there to be some overlap. So I'm gonna check it out again. I got a different example here to work through. I'm gonna step into pointers. I spent a little bit of this weekend reading about pointers, so I'm not completely blind, but I've yet to work with them, like really focus on them. And and then also checking out interfaces again too, because I did it last time. It worked out well. I felt like I understood it, but I feel like touching on that again is going to be good for me. So really 3 goals tonight. No testing in this tutorial or in this not tutorial in this stream. Just these 3 things, and I have a few examples of each one. So okay, so I'm gonna go ahead and jump into this. By the way, remember if you want to see these repos I'm working on, go to the bottom of the channel or in the description, and you can see a link to all of these. Also, if you go to any of these repos, you can see here that I'm just literally building off of them. So if you click here, these are all templates, and they're built from the previous streams templates. So you can literally click back to the first one like that. So you can follow and see the entire journey that way if you'd like to. Um, Sidebar. Okay, so I'm gonna get us started here. Today I'm gonna be working inside of just one file. Oh, hey Siri, set a timer for 30 minutes. 30 minutes starting now. There we go. Okay, let's do it. Okay, so I have, for this little thing here, I have most of this code written inside of separate functions. So I can just call these functions inside of my main. And I tried to make this mouse themed. because I feel like I'm developing a little bit of a theme here. Okay, so I need to get FMT imported in because that's my um, ability to do console logs. Cool. Um, and then I need to. The first thing I'm gonna do is I'm gonna work on Go routines. So I already have the name of a function I'm gonna work on. Let's go ahead and put some comments here. So this first one I'm going to work on is going to be called simple mouse routine. For each of these three things I'm looking at today, the Go routines, pointers, and interfaces, I have two examples, one simple and then one a little bit more complicated. I figured that that might be a good way to learn today. So this is going to be called simple mouse routine. And this is going to use Go routines. And another thing I'm going to try this time is there is the ability to use this thing called weight group. And a weight group can be aware of when Go routines are done. I'm not sure how it works. I'm going to have to look that up, but that's one thing I want to try out today. So this will use a weight group from the sync package to handle multiple Go routines. And what I know right now is that a weight group waits for a collection of Go routines to finish executing. Okay. So the function is going to be called um, simple mouse routine. And I'm just going to do a simple fmt.print inside of simple mouse routine. And then we'll call our function down here. Cool. And I'm going to keep the main simple, real simple. This will only be used for executing all the functions to demonstrate the concepts. Okay. So by the way, if you're learning GoLang, GoLangBook.com is the shiznit, the shiznit, the bee's niece. Okay, this book, this online book, has everything you need. Literally, just Google it. It pops up. You can buy it. It's also free. The free version's here. Um, so I kind of use this. Whenever I've Googled, I've found that these pages are the best learning resource that I've found. So I usually end up here. Oh, it says the book is no longer available for purchase, but you can still get it here. Oh, okay. Oh. Okay, so let's make sure this function works. Cool. Okay, so let's go ahead and jump into this. Okay, so the first thing I need to do is import a package called sync. And sync provides basic synchronization primitives such as mutual exclusion locks. Other than the once and the wait group types, most are intended for use by low-level library routines. High-level synchronization is better done via channels and communication. Values containing the type. So, okay, I feel like I need a better definition. Hmm. I really hate when people charge for articles. I mean, I get it. You gotta make money, but it is annoying. Mutual exclusion on shared resources. Huh. Don't you just love it when you look up something that you don't understand and the explanation you also don't understand? It's like you didn't help me at all. You ain't helped nothing. Useless. Okay. Sync wait for Go routines to wait for the completion of a collection of Go routines. Okay. This waits for a Go routine to wait for the completion of a collect. Wait, so one Go routine will wait for the completion of another group of Go routines, or okay, I don't know. Wait group holds an internal counter. If this counter is equal to 0, the wait method returns immediately. Otherwise, it is blocked until the counter is 0. To increment the counter, you have to use add int. To decrement it, we can use either done, which would increment by 1, or the same add int method with a negative value. In the following example, we will spin up 8 Go routines and wait for their completion. Okay, so this will add one. Oh, so every time the Go routine is created and ran, we will add one to the wait group. And then when the Go routine is done, we will, at the end of it, we'll call done. Okay, I get this. And then this right here will wait. I'm not sure what this part will do. Uh, I guess because this loop can happen and the loop can be done before the Go routines are done. So this would force our code to wait until the Go routines are done with what they're doing, even after the loop has been broken out of, is what I'm getting. Okay, and then after the wait. Okay. I think I get this. I think I get this. So first we need to bring in the wait group, or set up the wait group. Var wg sync dot wait group. So wait group will hold a counter that keeps track of Go routines. Go routines are tracked by adding wg plus add point period add one at the before or just before they're in, and when a or at the end of a Go routine, call wg.done to decrement the counter. wg.wait will wait for all Go routines to finish based on the counter getting back to 0. Okay. That makes sense. Also, I'm mad that I did not do this in a multi-line comment because I'm trifling. Okay, so let's go ahead and write our code here. So we're going to basically make a loop. We're going to make a set of tasks. How about that? We're going to make a set of tasks, and then we're going to loop over them, and then we're going to have these tasks run inside of separate Go routines. And then we're going to wait for all of them to be done. So, tasks. And these will just be strings. running or painting. I wish I could do all these things at once. Wash dishes and laundry. I literally have laundry in the washing machine right now, which is why I have to go here when my alarm goes off. I've been struggling. Okay, it's the holiday season. Oh, I did this wrong. Let me fix this. It's the holiday season. You know what I'm saying? I don't even like to do laundry anyways, but I have the excuse of holiday season, so don't judge me. Okay, so we're gonna iterate over the tasks and create a Go routine for each. So for we don't need the index task, and then we use the range from the tasks. We need to put an S here. We use the range of the task. So this will get us. This will go over all of these and give us the value of each index as the variable task. Okay. And then we can create a Go routine. The fact that it's a Go routine is because of the word Go in front of a function. And this is an anonymous function, so it's not named. So we're going to call it right when it happens, or like right when we write it. Oh, this T represents the incoming task. I'm going to call this incoming task. That's what I like to do with my functions. For now, at least. I find that that's just easier for me. Okay, so defer wg.done. So this will wait until everything is done, right? What does defer do again? Yeah, defer will always go last. Um, After everything else, even if it's written first, it'll always go last. So this will decrementing the counter when the Go routine completes. Okay, and so inside of this Go routine, I want to do fmt.print, and I'm just going to print the name of the task. Let me change this first because I need to make a sentence here. Okay, make a cute little sentence. So we'll say the mouse is, and we're gonna format. So we're gonna interpolate some string stuff here, and we're gonna put inc task like that, and then we're gonna pass the task into this anonymous function when it runs. Okay, so this is going to do all of these, all three of these, and at the end of all this, we need to do the wait thing, like I mentioned. So wg.wait. And then after all the Go routines have finished, so this will wait for all Go routines to finish. After all of that, then we need to print we'll say simple mouse routine, all tasks completed. Okay, so this will only print when all of the Go routines are done. So I think I can run this, and then we're going to clean it up and like add some more comments. Something didn't work here. Hmm. Oh, oh, I forgot. I have to add to the wait group counter. Okay, so I need to at or before the go routine happens, each loop add to the counter. So this will, yeah, this will make sure all the routines happen, I believe. I hope this works. Yeah, that worked. So one thing I need to do is fix the formatting here. Okay, so that's better. Okay, so that worked. Let me get rid of this extra console log. So that works. Um, a typo. Okay, I think that's good. Is there anything here I don't understand? Iterate over the task and create go routine for each task. Oh. Hmm. You could also do add with a negative number instead of done. Those do the same thing. I'm gonna steal this note here. Actually, let me reformat this and make this a little nicer. And then I'll include that in my note as well. So if the counter is 0, it will unblock the code after it. So this is a code blocker. It's a block stopper. A block and stopping. Okay. Just gonna add some color, some style, some fashion. Okay. Okay. Cool. Let's go ahead and knock out another Go routine thing here. And then by the time I do this one, my laundry probably needs to be put in the dryer. So this next one's going to be called Advanced Mouse Routine. Just going to pop that under here. Oops. I need to do funk. Okay. Okay, so we're going to do the select statement again, and the select statement allows us to work with channels to pick up communications from those channels and store them in variables that we can do some behavior. The select is kind of similar to like a switch statement, syntax wise. Okay, so um, this function to demonstrate the use of the select, is lowercase, statement with channels. This will include timeout handling and non-blocking channel operations. Okay, so for this, we're going to have two channels. So to make a channel is C1 make chan, and this channel is going to hold a string, and C2 make chan, and this channel is going to hold a string. And channel comes from, I think it's just built in. Yeah, I don't have to do anything to get channel. Oh, this is just a name. Wait, I'm confused. Where does channel come from again? I can't remember. Um, okay. It's just a keyword, I guess. That makes it easy on me. Okay. So we want to start to separate go routines simulating different tasks. By the way, this rain sound in the background, I hope you can hear it. It's very relaxing. So we're gonna use a timer here. This is gonna be a timer that will last 2 seconds. Because go routines happen so fast that we need a way to be able to observe them just for experimentation purposes and whatnot. And also to see something happen in the terminal. But GoLang is very fast, so that's why that's like that. And then what we do is in this Go routine, when the Go routine has done its business, which for this is just to wait 2 seconds. Oh, mess that up. This needs to be second. And we need to bring this in from time. Okay. Yeah, so when it's finished doing its business, which is just to wait for 2 seconds here, then we need to send a message to the channel. And the special syntax is just an arrow. Well, I got oats in my teeth. Okay. So like this, and then we say mouse is finished. What was mouse doing earlier? Let's say painting. Okay. And then we want to call this go routine as it's written, so it's an anonymous function. And then we want to do another one. Let's do another one here, and we're going to make this one similar. It's just going to last 1 second instead of two. Actually, let's make it last 3 seconds. That's fine. And then we're going to return this message to channel 2, and mouse is finished doing laundry. Okay. Okay. Um, Now We need a timeout. This timeout will happen. So what timeout does is timeout will actually um, timeout will have it has its own channel, and we can pull a message from that channel. Basically, I remember that part. We did that last time. And this will be. Let's set this to 4 seconds. So time dot after has wait. I don't think I know how this. I know that this works if I return this. If I have this as a case, but I don't think I understand. Hmm. So okay, I think. Oh, I think I know what's happening here. So it acts like a channel. I don't think this is explaining it well because in my example, it acts like a channel. It's just that we're not going to store it in a message. So because we're not going to use it in the logic after the case. So it just ends up getting returned. Okay. It doesn't feel equal, right? But let's just go with it for now, and we'll have. I guess I'll have to just look into it a little bit more. Maybe I should watch a tutorial or something about it. Okay, so this is gonna wait 4 seconds, and then we need to have a loop for the select. So using select to handle multiple channel operations. And also learn too that Go routines don't necessarily have to happen like on in parallel because even if it's like one processor, a processor can hop back and forth between running Go routines to make it appear as if they're happening at the same time, but they're not. And parallel processing happens simultaneously, but concurrent things can just happen separately. That's how I understand it. That's a side note. Okay, so this is my loop. It's going to happen twice. We're controlling it to make sure it happens twice. No, we want to make sure it happens 3 times because it's going to be 0. It's going to run 1. It's going to run. Oh no, it's going to happen twice. It's going to happen twice as long as I is listened to. Yeah. So okay, so select and then we need a case. Wait. Okay. Case message 1. Ah, ah. Okay. 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 Um, I can finish this before I go. Take my laundry out. Print line Okay, so now I can use this message in this, and we got another case. It's going to be pretty much the same. It's going to be for the second go routine, which is message 2. Okay. And then we have the last go routine, which is just going to be timeout. So this right here. This is not going to, we're not going to capture the message from this timeout, but we still want to have whatever the channel is be returned. Or we want to capture whatever's returned from this timeout. We're just not going to store it in a channel. Let me add thing here. And then we return here. So we know that it'll get 0, it'll go 1, it'll go. Okay, let me, okay. Let's do a default case and default case for non-blocking select print line advanced mouse routine for tasks will complete sleep. Okay, so I don't know. I feel a little iffy about this, but I think this might work. Let's go ahead and give it a run. I'm gonna just only do this one. Okay, so I did the 2. The timeout didn't do anything. Let's set the timeout to 3 now. Oh, it didn't do it because it will have done this. And this takes 3 seconds. So let's see if we set it to 2. Then we should only get the first one. No? Now what happens if I turn off these time to sleep? Then it will only ever have gotten the first one done, and it's probably not guaranteed. What if I make this really long? Then the timeout should happen before, right? I don't think this makes sense. Time dot 1 second, time after. Okay, let me go back and look at how I did this in my previous. Oh, excuse me. I think it was 3. Yeah, it's supposed to wait. Um, Maybe the default case is what the problem is because it's going to the default case. Yeah, that could be it. The default case is catching instead of letting the timeout thing do its thing. That's what it was. Okay. Okay, so I should note that if there is a default case, the then it will be activated. Wait, let's see. Yeah, it'll be activated, and then this will keep going, and it'll only do it twice, so it's not going to like keep checking. So if I set this to like something higher, like 10, it'll at least make it here. What if I did it to 3? It should make it to the timeout if I do it for 3. Yeah. Okay, so what if I set it to something really, really high, like 1,000? It makes it to the timeout. Okay. Okay, that makes sense now. If there's a default case, then it will be activated uh, every time the other cases aren't activated and the timeout. Okay. That's really what it is. The fact that the timeout didn't show up really had to do with the fact that the loop only goes through twice. Um, so I could do a while loop and just let it keep running, and the time, but the timeout is the only thing that's going to stop it. That's the only thing. So that's like more risky. But I feel like that would make more sense for this, but it's fine. That's what it is. Okay, I think I can take a short little break here for, I'm going to say 10 minutes. I need to go get my laundry, put it in the dryer, and yeah, I'm going to go do that. So stay with me, stick with me. You should take a break too, actually. You should go for a walk. I'll catch you in a little bit. Peace. Yo, 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 I'm back. Rah, rah, rah. We about to get buff doing some GoLang. It's not that serious, but you know what? Kind of is. Okay, let's do this. Um, we've done some Go routines. We're gonna jump over into pointers, do some heavy lifting tonight. Okay, I think this might be the more complicated part of tonight for me because pointers are new for me. Um, yes, I am. Okay, we're just gonna do this and see how it goes. Okay, so the first one I'm gonna do this a new function called simple pointer, and we're gonna add that right here. Okay, so this is just gonna be real simple. The simple pointer demonstrates the use of pointers and Go. Pointers reference the memory address of a variable. I feel like I understand the basic part of a pointer. I mean, just as it says here, whenever you store any kind of data, it stores it in a specific location in memory, which is like some weird number. It's some weird looking thing, right? And the gist of a pointer is that normally when you take a variable and you use it, you're passing it around, you're passing the actual data structure around and you're moving it into like different locations and stuff like that. But sometimes you have data that's too big or it's just slower to move it around and reassign it to different variables and use in different places. So instead, you store it in one place, and then anytime you want to use that data, all you have to do is just pass the location where that data is stored, and then your code can use it. That's as much as I understand. So I was trying to figure out the other day when I was looking into this, like, what is the advantage of using a pointer, and like, in what situations would I actually use it? And what I gleaned is that a pointer is just useful in situations when you just have a lot going on, like a large amount of data. Like, for example, if you had gigabytes of data, you wouldn't want to just store that in a variable. You would want it stored in one place in memory, and then you'd want to just reference it or manipulate it or whatever. So there might be more to it, but that's what I understand at this point. So okay, so let's make our function here. And we're not going to do a pointer for the argument or anything. We're just going to make a pointer inside here. So we're going to keep track of some cheese pieces for Chucky, Mr. Cheddar. Wait. Sidebar, Mr. Cheddar is the bee's knees. If you don't know Mr. Cheddar, you are not hip. Mr. Cheddar is like the first, officially the first meme made by AI. Mr. Cheddar. Hope you're having a good day. Okay, yeah. Let's not go down that rabbit hole. Um, okay, so we're gonna keep checking some cheese pieces, and he's gonna have 10 pieces of Gouda cheese. Mister Cheddar be liking the cheese. Boom. Okay. And then also we want to have a pointer. So this cheese pieces normally we treat this as a namespace that has a value associated with it, and then this namespace. Um, I don't. I guess I don't think I quite know. Like if I were to use this namespace to do a calculation, I'm not sure what the inherent difference is, to be honest. But this is how we do a pointer. So pointer to cheese. We still do a regular assignment. And then to get the address, we use the and symbol. So we can console log here, or we can format print address to Mr. Cheddar's cheese pieces. Let's go ahead and see what that looks like. Non-declaration statement outside of function body. What? Line 80? Oh, we need func. That's why. Okay. So this is the address. And this address, I guess, is going to keep change. No, it's not going to keep. Oh, yeah, it does change. Okay. So this is Mr. Cheddar's cheese is at this address. And what we can do is we can, instead of changing the variable, we can go straight to the address, and we can access the address by having a namespace or going to the pointer using a star and then assigning it 20. Before I print this, I would like to just print. Oh, no. Wait, what does the star mean again? Okay, star is how you get the value. So, um, let me make a comment for that actually. To get address or to access address, use symbol. To access value at an address at a given address, use the star symbol. Front of pointer, and then this one is in front of variable. Okay, so we access the value, and then we set that value to 20. Okay, and so with this, what we can prove is that we set the value. So print simple pointer new number of cheese pieces equals, and we're going to do the digit and cheese pieces. Pieces. It says cheese pieces. Okay. Let's go ahead and run that. Now we can see here. Oh, we messed up. Did we mess up? I need to do print F. Okay, new cheese pieces is 20. Cool. Okay, that wasn't too bad. So I feel like I don't have an issue using pointers, at least in this context. I just have an issue like knowing when it's appropriate to use one, and probably because I just have not done the kind of code that warrants pointers, to be honest. Um, so, anyways, let's go ahead and move on. I'm gonna make an advanced pointer, and this is going to involve uh, a struct and a method as well. So pointer. Hey Siri, set a timer for 25 minutes. I forgot to do that. Okay. So advanced pointer. Let's make a new function here. Pointer will. My casing's off. will keep track of mouse movement. Or mouse location. What I'm gonna do is I'm gonna make some coordinates and I'm gonna change these coordinates and it's gonna tell me where the mouse is, which is a great tie into like the next stream because I'm gonna do like a little mouse game. It's not gonna be a coordinate game, but it's just gonna be like a little. It's gonna be like a little text-based maze. Well, kind of coordinates because it's gonna happen in it's gonna happen in an array of text strings that basically creates a grid. Okay, so let's make our function here advanced, our func advanced pointer. For this to work, we need a mouse struct. To represent the XY coordinates. So type mouse struct X. If you have two variables that are the same type, or two, these are not called variables, these are called fields. If you have two fields that are the same type, you can do them on the same line. 64 is going to be a float value. These could be integers, I suppose, but I'm going to leave this float. I'm not sure why my little reference made them as floats, to be honest. Okay, so we're going to make a method for the mouse, and this method is going to control the mouse moving. And this method is going to use a pointer to refer to the mouse struct that it's working with. So, okay, this is interesting. Okay, move will be a method with a pointer receiver, allowing it to modify the mouse struct. It is called on. So normally when you have a method, you give it a variable, or you just give it a struct, which is stored in a variable, and then you can reference that variable. But here instead, we're giving it the address, or we're giving it the value for, we're giving it a pointer. We're giving it the value of a pointer as opposed to a namespace with the variable, I think. So function m star mouse. This is a pointer. This is a pointer to this is the value of a pointer. This is a value at an address in memory. That's what that means. At an address in memory for whatever mouse has been created and is using this method. So this is the value assigned to the pointer. That's the value of the pointer for the mouse used to call this method. Okay. So the method's going to be called move, and it's going to have dx and dy, and these are going to be float 64. So m plus, or m period x, this is the mouse's x coordinate. We're going to change it to whatever the move x coordinate is, so it's going to be dx. And then we'll do the same thing for Y. We're not changing it. We're just adding to it, basically. We're incrementing it up by whatever is incoming. So dy. Okay. So that's cool. Now we need to actually create a mouse from our struct. So we're gonna give it x of 3 and a y of 4. Um, what? Oh, I keep making these parentheses. These need to be. I always do that. I'm so used to. I don't know what I'm used to, honestly. I don't know where that would have made sense. That definitely would not have made sense in JavaScript. Okay, so now we need to call the move method. So m.move, and we just want to move it over 5 and down 2, which is -2. So right is 5. Right is in the plus direction on the x-axis. Left is on the minus direction on the x-axis. Up is on the positive direction on the y-axis, and down is on the negative direction. So we're moving it over right and down 2. And move needs to be capitalized. Okay. And then fmt dot print line, or let's print f. Ugh. Advanced pointer, new mouse position, and then okay, my little guide here has some weird. I'm gonna try this. I don't even know if this is gonna work. It has a weird um it's got some weird stuff going on here. I've never seen this before. So plus percentage plus V. What does that do? I have no clue. Let's try it. Hmm? What does the plus do? Oh, it will have the keys and the values. Okay, not just the values. Oh, okay. Let me look that up, Mr. Cheddar. Gotta love them. Okay, so percent plus v, and that is in print f, GoLang. Okay, that did not show up. Help me out, I'm lazy. Help me out. Make it easy for me. Okay, this shows the fields by name. Okay, that's all I need to know. Let's go ahead and add that in here as a little. It's cute. It's adorable. It's adorable. It's very, very adorable. It's cheeky like a mouse. Who would have thought code could be cute? Okay, so that's cool. I think I'm ready to move on. Yeah, we're gonna do some interface stuff here. We got two interface functions to make. Hey Siri, how much time is left on my timer? Oh, okay. I feel like I've been doing this longer, but okay, I think we can get through these then. Let's see how fast I can get through these. If I got a straggler at the end, it's fine. I'm still taking my break. So let's make a second to last function here. Let's call this simple interface. And we make a function here. Oh, we got to put our comment here too. I'm been yawning so much. It's been a long day. I went to it wasn't a wedding, it was a hand tying ceremony, and then I went to go see the Beyonce movie. That stuff was long as heck. Oh my god, I was in that movie ready to go. It was good though, but I was like, girl, please, you got me held hostage up in this theater. I was in there for like 3 hours. That movie literally was 3 hours long. That movie was that movie was longer than the concert. Basically, that movie was long as heck. And it was good, and it was $30. I was like, girl, you must have did something. You had me spending $30 to come see a 3 hour movie for some songs that I love, but dang, girl. Anyway, that's neither here nor there. Okay, so for these interfaces, we're going to do some mousy things. So we're going to have. I think we could still use. No, no, no. Okay, I keep getting structs and interfaces mixed up. That's the problem for me. I keep getting structs and interfaces mixed up. A struct is just a collection of fields that are more or less like the properties of some object that describes a thing, whereas interface is a collection of methods that need to be satisfied um, in order for something to be considered the type of that interface. So structs are used to make things like of the same category, or rather, and interfaces are used to make sure that a method has been associated with a thing in order to be classified as such. That's yeah, that's what I'm going with for now. Okay, so let's make an interface. So interface to define the method signature for mouse activities. So type mouse activity interface. And this mouse's activities will be performed, and this performance will result in a string. So any type that satisfies this mouse activity is going to have a perform method on it. And we're going to make a struct. So struct to represent the running activity with a speed attribute, which is also known as a field. So type run activity struct and speed. This would be like some type of number. Okay. We need to actually define the perform method. So perform method for run activity implements the mouse activity interface. So we don't reference mouse activity. We reference the struct, and we reference the struct and then just attach the method to it. And then wherever we want to use the mouse activity, we have to make a new uh, thing from the struct, and it'll work as long as the struct has the method on it. If that makes sense. So it's kind of like that. It's like that. Okay. If you don't get it, you see what I'm saying? It's all like this. Do you understand? That's how it is. Okay. So func, and for this one, the activity is going to be referenced um, with the argument or with the variable called r, or this argument um, r, and that's going to be run activity. So inside of the method, if we want to refer to the struct, which is run activity, it's going to be called r. And this is going to be called perform, and it's going to give us a string and return. We're just going to return a fmt.sprintf. Oh, I spelled that all wrong. And we can format this speed since it is a float value. We can do %.2f. I think this means to the two decimal places. So that's my theory. R.speed. Okay. Um, no, see, the only thing I don't like with all of this is like it just takes so long to get to something that we can test. That's my only gripe. It's like I feel like I'm just having to do a bunch of stuff, and I'm not sure if it means anything until later on. I don't know the difference between printf and sprint. What is sprintf versus printf? In GoLang? You know what? I think they have the same syntax, so I'm just going to go ahead and we'll get to actually see this in the terminal. Actually, what I can do is I can make a new mouse here or a new activity. Well, let me go ahead and just do simplification. I'm going to have to do it here anyways, so it's fine. So var activity, and this is going to be using the interface mouse activity, and this will basically come from a new run activity. We're going to give it a speed of 5.0. Okay, and so we can print this as well. So fmt.printf. Oh, I see. Sprintf doesn't write to the console. It just takes some text and it puts it together. So this is just like a better way than string concatenation, but this doesn't actually print to the console. It's just a way to format some string. Okay. Okay, that makes sense. That makes sense. So simple interface mouse activity and then SN activity dot perform. Let's add a comment up here, by the way. Sprint F will not print to console. Will just format some string. Oh, we gotta call the function. Okay. I think we can do this now. Cool. So I'm curious to see what happens if I return a console log. I know you shouldn't do that, but is it going to tell me I shouldn't do that? Oh, yeah, it doesn't like that. Okay. I knew that wouldn't make sense, but I just wanted to see what happened. Okay, so yeah, there we go. We're using, and I know what would happen if I got rid of this method here. Then this method would getting being gone would mean that this run activity no longer satisfies the requirements for being a mouse activity because it would lack the perform method that is needed to be called here, because it's defined here, or it's defined here. Okay, cool. Whew. I am so tired. It's been 10 minutes. I think I got 3 minutes. Do I just push through or what? Okay. It's 12:30. Okay, I'm gonna push through. I'm just gonna push through. Oh, okay. We got one more. Yeah, let's just go ahead and knock this out. This is advanced interface, and func advanced interface, and for this we also need to have a struct. So this is going to be called dig activity. Also, I think that it seems like structs interfaces both have capitalized names. I've noticed that. Okay, so dig activity will represent the digging behavior with a depth attribute. So when you dig, you can dig a certain distance. And then the perform method we're going to reuse the mouse activity. So so the perform activity will be bound to the dig activity structs. Okay. Okay. Um, so type dig activity, this is our struct, and depth float 64. Okay, that's simple. And then we need to make the, we don't have to make a new interface. We're going to reuse the same interface as before. We just need to make sure that this dig activity has a method on it, the correct method on it. So func D is a reference to the dig activity that has been created within the method. Like a way of saying this. So dig activity perform string return fmt dot sprint if sprintf, and then we're going to say digging to a depth of 2f, or this right here is percent dot 2f is a way to format a decimal to the 100ths place. Okay, so now this is set up. The perform yeah. So a mouse can run and it can dig. Okay, so let's get this function set up here. So activities, we make activities, digging and running, and that is going to be a slice of mouse activity since there are multiple ones. No. Yeah. So dig activity and run activity are both structs that satisfy the mouse activity interface because they both have perform on them. So therefore I can make a slice of mouse activity. Let me write a comment there. I feel like there's a cheese joke I'm missing here with the whole slice thing. Maybe next time I'll get it. Okay, so we're gonna put run activity, and we're gonna give it a speed of 50 or 30. That's what I pushed. I'm gonna stick with it. And then we're gonna give it a dig activity with a depth of 300 because this is Minecraft, y'all. Y'all, we gotta make these decimals too because they're float 64. I'm gonna have to see what happens if I don't do that. I'm gonna try to break it here in a second by giving it an integer. Let's see if there's, I don't know if there's coercion for that kind of thing for like fields. So iterating over different activities, demonstrating polymorphism. I have to look that up. I don't know what that means precisely. So we want to iterate over all activities. So we use our good old friend for loop. So for, I'm not going to use the index for act. Range of activities, fmt.print, and then we're going to say advanced interface mouse activities and percent %s and act.perform. And this should always work because all activities here are mouse activities and all of them have perform. What is this telling me? Print Oh, I need to do printf. Okay. Let's go ahead and run this. Cool. I'm seeing the right thing here. What happens if I take away the decimals and make these integers? Does it break? Oh, nope, it doesn't. It just coerces it. Okay. I'll take it. I mean, it coerced it here. Well, no, that's actually a decimal. I thought there was a place where I did it where I didn't actually make it. I guess there isn't. Oh, well, this is these coordinates. They did coerce actually because these are supposed to be float 64 as well. Okay, so yeah, it will coerce the numbers. That's convenient because I'll probably be forgetting. Let's run all of these. Um, Mouse position. Oh, mouse position is move. Um, Actually, it didn't. I guess if I had made it into, I don't know why this advanced pointer part here didn't coerce into a, why here it didn't make these values next to the fields into floats. I'm not sure why. I mean, they're not floats here, but on the typing, which is we're just changing the values here based on this. I don't know why that it's interesting. If I were to change these by decimals, would they um let's see. Yeah, it does. It does. Oh, this is interesting too. I'm sure there's a math reason why this doesn't actually get to be exactly zero point 0.7. That's interesting. Okay, I'm not going to fixate too much. That this does what I need to do. All of this works, and yeah, I'm so tired. I should just go ahead and say a few words and then get off here. Let me go ahead and commit first. And I still have a couple of things I need to do before I get off of here as well. Okay. Um, Last thing before I switch my screens back, let's look in here to make sure there's not some things that I want to add to comments. Um, okay. I know that these exercises will only get me so far as well. I really just have to, at some point, jump in and start making something in order for it to be more clear. But these past four parts of this introduction, I think, have just gotten me like in the flow, which I can leverage and take to the next step. So I ain't mad at it. I'm not mad at it at all. Did I push already? Okay, I already pushed. Cool. So um, words of inspiration. Um, yeah. So I will say gratitude is really important, and in the journey of trying to become whatever it is that you have, like, you know, in your mind, whatever you're trying to manifest for yourself or to become yourself, gratitude is important. Um, you need to be grateful regardless. And gratitude is not something that you can get from other people. There's plenty of reasons to not feel it. But I'm telling you, if you can find a way to be grateful for whatever you have, wherever you are, whatever you are, it's going to make this journey a lot easier because otherwise it's a burden and it distracts you. It gets in the way. You know what I'm saying? The negativity, the negative energy, the negative mental landscape that you will have when you are not able to cultivate a deep sense of continuous gratitude, it gets in the way of you trying to pursue great big things. And you, in order to grow and to become what you want to be, which I know is amazing because you're amazing, you need everything you can get. You know, you don't need to waste your time or your energy with negativity. You know, you need to be able to look into the mirror and be like, yeah, I got this. I can do this. And I believe that you can, and you should believe that as well. You know, so gratitude is one thing, and the other thing is even if you struggle to feel gratitude, learn the fine art of putting putting that self-judgment aside so that you can focus on being in the here and the now. You know, as you're learning anything and growing and whatever, it's it's bound to be a roller coaster. You're not always going to feel your best every day. Some days you may be tired. Some days you may be unmotivated. Some days you may look at your efforts and think of yourself very poorly. Um, Even if you cannot find the energy to be like, yeah, I'm awesome, it is a worthwhile skill to learn to just put all of that aside and just have an inner peace and to just let it be what it is and to just accept things for what they are. Um, the main thing in either situation, whether you're grateful or you're just cruising along and getting by with what you can, is that you focus on your goal. You know, keep your eye on the prize, and you don't let things push and pull you away from your track, from your path. You know, I believe that all of that, and probably other things that I'm not talking about or thinking at the moment because I'm so tired. All of that, I believe that those are the things that people who are excellent and amazing do. You know, a lot of it comes down to focus and continuity. And there are so many things in life that really things in your head that get in the way, you know. Um, People want to say that it's money. At times it can seem like privilege. At times it can seem like, oh, the door isn't open. At times it can seem like maybe I'm just not blessed or chosen to do this incredible thing. Screw all of that. Okay. Your goal is to show up and to do what you need to do and to get some business done. Let the rest of the world handle all that rejection, acceptance, whatever, blah, 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 blah. Your job is to show up and do what you got to do, handle your business, and keep it pushing. And everything else will get in line as it needs to be. You may not get where you think you're going, but you're going to get somewhere cool. You may not become what you have exactly imagined in your head, but you're going to be something awesome. You know what I'm saying? So just show up. And anything that makes you feel negative or bad, like you're like you can't do it or like an imposter, like you gotta work through that. You know, you either have to defeat that or you have to find a way to ignore it. Because at the end of the day, you can be all that you believe. You absolutely can do it. It wouldn't be in you to try and to want something if it wasn't possible when it comes to your dreams. So gratitude is the path that I choose because I feel like it's the easiest. um, and if you're grateful, the last thing you want to do is waste it. You know, when you're truly grateful for your blessings and everything, you're grateful just to even show up and do something cool like this. You don't want to waste it. You know, so. Anyways, that's my soapbox. That's my message. That's my philosophy for the day. That's the mathematics. I'll catch you in the next stream. I don't know what it's going to be. Obviously, I don't be planning these. I just hop on here whenever I got some spur time and inspiration. And I always got plenty of that. So the next one, like I mentioned at the beginning of this stream, I'm going to be jumping into a project. It is a prefabricated project. But it is going to help me. It's going to be a bridge. It's going to bridge for me so I can get started in that direction as opposed to doing these introductions. I think I've been introduced. Okay, not perfectly, but well enough to get it going. So thank you for watching. I'll catch you later. Peace and blessings to all of you out there. Come by and check me out again. My name is Key.